Hi students, welcome to physics classes. Now we will discuss about chapter kinematics for IIT Foundation. Now what is meant by kinematics? What is the definition for kinematics? Kinematics is the branch of mechanics which deals with motion of the bodies, which discusses about motion of the bodies but without considering cause of motion without cause of motion, that is kinematics. Now here we will discuss about motion in one dimension. Motion in one dimension in the sense body moving in a straight line path. If a body moves in a straight line path, its motion is referred to motion in one dimension. Its motion is referred to motion in one dimension. Frame of reference. In earlier classes, we have discussed about body is at rest, body is in motion. And the body is at rest means it is not changing its position with respect to surroundings in a given time. We are saying here surroundings means observer, in a time means a clock needed. That is what frame of reference. Frame of reference. A set of coordinate axes along with observer and a clock is known as frame of reference. This frame of reference is used to describe the motion. An observer should set a frame of reference relative to which motion is analyzed. So that we need x-axis and y-axis, like coordinate axis and observer means it is an origin we can take. It is origin axis, coordinate axis, and a clock is needed to define the time. Next, inertial and non-inertial frame of reference. Now, a reference frame. Reference frame means what are there? Coordinate axis and a clock to observe the motion of the bodies. If that reference frame is at rest or moves with uniform velocity, that reference frame is either at rest or moves with uniform velocity, that reference frame is known as inertial frame of reference. If the reference frame is at rest or moves with uniform velocity, reference frame is either rest or moves with uniform velocity, that reference frame is known as inertial frame of reference. If it is accelerates, if the reference frame is accelerates, that is non-inertial frame of reference. If it is at rest or moving with uniform velocity, means simply we can say not accelerates or rest, then it is inertial frame of reference. If it is accelerates, that is non-inertial frame of reference. Next one is distance. Distance is actual path length is known as distance. What is the length he traveled? What is the path he traveled? That path length is known as distance. SI unit of distance is meter. CGS unit is centimeter. Next one, displacement. Displacement is the shortest length between initial and final points. Whatever the path it traveled from here to here, the shortest length between or straight length straight path between initial and final point is known as displacement. Displacement SI unit meter, CGS unit centimeter. If a body moving in a straight line path, initial point is x1, final point is x2. So displacement covered here, displacement is x2 minus x1. Displacement is x2 minus x1. x2 is the final point and x1 is the initial point. Final point minus initial point. Now here, when the body moves in a straight path, magnitude of distance is equal to magnitude of displacement. Magnitude of distance equal to magnitude of displacement when the body is moving in a straight path, and remaining all other situations, displacement is less than distance. Displacement is less than distance, or we can write distance is more than displacement. So from these two situations we can relate this displacement is less than or equal to distance. We can relate displacement is less than or equal to distance, or we can write displacement, ratio of displacement to distance, less than or equal to 1. Here distance is always either 0 or positive. Displacement, it can be 0, it can be positive, and it can be negative. Distance 0 and positive, displacement 0, positive and negative also. Distance cannot be negative. Displacement can be negative also. Next, average velocity. Average velocity is the ratio of displacement covered during a particular time interval. Now we'll take an object started from x1 in a time t1, position x1 in a time t1. It traveled up to x2 in a time t2. Now what is the average velocity? Displacement x2 minus x1 time t2 minus t1. So we can write change in displacement by change in time taken, delta x by delta t. Now here instantaneous velocity in the sense velocity of the body in a particular instant. Velocity of the body in a particular instant is instantaneous velocity. Here in instantaneous velocity time tends to 0. So limit delta t change in time tends to 0 delta x by delta t. So when time delta t tends to 0, we can write it is dx by dt. dx by dt. This is what? Instantaneous velocity. Velocity has both magnitude and direction, so it is vector quantity. SI unit of velocity meter per second. CGS unit of velocity centimeter per second. SI unit is meter per second. CGS unit is centimeter per second. Next one is uniform motion. Uniform motion means if a body is moving, velocity of the body is constant, same throughout its journey. Velocity of the body is same for throughout its journey. Then its motion is known as uniform motion. Velocity is same. Velocity is not changing. Velocity remains same, constant. Velocity constant means same. Velocity has both magnitude and direction. Both magnitude and direction. So that motion magnitude is constant. Sir, what is mean by magnitude? Some of the students will have doubt in the magnitude. Magnitude in the sense numerical value with its units. 10 meter per second is the magnitude. Towards north, south, east, west, these are directions. So magnitude and direction is a constant throughout its journey. For example, if you take from point A to point B, entire its journey, it has same velocity, no change. Then its motion is known as uniform motion. This motion is known as uniform motion. Now if velocity changes, either magnitude or direction changes, if it is changing, this motion is non-uniform motion. Next, average speed. As we discussed, average velocity, average speed is total distance, ratio of total distance to total time taken. Now in previous case we see in uniform motion. In uniform motion, magnitude of velocity is equal to speed. Magnitude of velocity is equal to magnitude of speed. But if the body is moving with uniform speed, we can't say it is having uniform velocity, because in speed there is no particular direction, but in velocity there is a particular direction. That's why in uniform motion, magnitude of velocity equal to magnitude of speed we written. Speed is not having any specified direction. Speed has no specified direction. It has magnitude, but the direction is changes. So speed is a scalar quantity. Speed will be either 0 or positive. Coming to the velocity, it can be 0, negative, positive. Speed positive and 0 only, but velocity 0, negative, positive. Speed cannot be negative. Speed cannot be negative. In velocity, we have taken displacement. As displacement becomes negative, velocity also can become negative. But speed, we have taken distance by time. Distance won't be negative, so speed also won't be negative. Speed has same units like velocity, meter per second, meter second inverse, or centimeter per second, centimeter second inverse. This is SI unit. SI unit is meter per second. CGS unit is centimeter per second. Next, average acceleration. Now, we discussed about uniform motion, non-uniform motion. In uniform motion, velocity of the body is constant. Uniform motion, velocity is constant. In a non-uniform motion, velocity changes. Magnitude and direction of the velocity changes. If it is changing, that is non-uniform velocity. For uniform motion, acceleration is 0. For non-uniform motion, acceleration is there. So here we will consider non-uniform motion. So when the body started at point with a velocity, we can take v1 and travel to some distance, its velocity becomes v2 in the time t1, t2. So rate of change in velocity v2 minus v1 by t2 minus t1. Rate of change in velocity of a body is known as acceleration. We can write this change in velocity is delta v and change in time is delta t. Delta v by delta t. So like velocity, we have taken instantaneous velocity, instantaneous acceleration. Instantaneous acceleration means delta t tends to 0, limit delta t tends to 0, delta v by delta t becomes dv by dt. Acceleration equal to dv by dt. Now this a equal to, we can write d by dt of v, and we know v means dx by dt. So we can write this d square x by dt square. Acceleration equal to d square x by dt square. Now this acceleration we written in terms of velocity. As velocity have direction, acceleration also has particular direction. So acceleration also vector quantity. What are the units of acceleration? Meter per SI units, meter per second square or meter second inverse square. CGS units, centimeter per second square or centimeter second inverse square. Now, if a body is moving in a straight line, and if its acceleration is constant, we will consider. Now for uniform acceleration, what does it mean? A constant or uniform acceleration means change in velocity is same, v2 minus v1. Change in velocity is same for all intervals of time. Change in velocity is same for all intervals of time. Then the acceleration is uniform acceleration. For uniformly accelerated motion, we have equations. Now we'll discuss the equations of motion. If a body started with velocity u and traveled after some time, velocity becomes v. So u is the initial velocity, v is the final velocity. Time taken here is t, and due to the change in velocity, acceleration is a and displacement covered is s. So we can write equations v equal to u plus at equation s equal to ut plus half a t square. Third equation v square minus u square equal to 2as. Fourth equation s nth equal to u plus a by 2 into 2n minus 1. Four equations. V is the final velocity, u is the initial velocity, a acceleration, t time, s displacement. Now this fourth equation, fourth formula is the special case in second equation. Second equation is displacement covered by body in t time. In t time, what is the displacement covered is s equal to ut plus half a t square. In that special case, t seconds in the sense from starting t equal to 0 to t. Time 0 to t. 0 second, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, like that 0 to t. Now particular second in the sense that tth second. Or example we can take first second, second second, 10th second, like that we can take examples. One particular second, distance traveled by the body in the t seconds, t time means 0 to t seconds. Distance traveled by the body in a particular second, 10th second, in that 1 second. In that 1 second is s nth. Here n is the time, nth second, distance or displacement traveled by the body, displacement covered by the body. Displacement covered by the body in nth second. In nth second is known as s nth equal to u plus a by 2 into 2n minus 1. Next we will discuss about graphs. Now we have different types of graphs. In that first one we will take position time graph. Position time graph, or we can say it is displacement time graph. Now this on x-axis we will take time, y-axis we will take position. If this graph is a straight line passing parallel to time axis, straight line and parallel to time axis indicates body not changing its position, so it is rest. Next same graph, position time graph, straight line passing through origin or straight line passing through some any point, like this. Equal displacement in equal change in time, equal displacement in equal intervals of time. So this is known as body moving with uniform motion. It indicates that body moving with uniform motion. Now if it is not straight line, non-uniform motion. Remember what axis we have taken. Displacement or position time graph. Curve is non-uniform motion. Whenever non-uniform motion is there, there will be an acceleration. Velocity time graph. In velocity time graph, x-axis we will take time, y-axis we will take velocity. Now like a previous situation, the graph is on x-axis. It is an x-axis. It indicates that no displacement, body is at rest. No displacement, body is at rest. Now in another situation, parallel to time axis, here different. Same graph, if you take here x position, we discussed body is at rest, but here velocity. So here this line indicates as time is increasing, velocity is not changing. X-axis is increasing, y-axis is not changing. Velocity is not changing, but time is going on. So that means uniform motion. Body is in uniform motion. Same velocity time graph, straight line passing through origin. Straight line passing through origin, or passing through some other point, or passing through some other point. That indicates that velocity of the body is increasing with time. Velocity of the body increasing with time, anyhow changing. So non-uniform motion, non-uniform velocity. So whenever non-uniform velocity we have, then it has acceleration. It is accelerating. Next, acceleration time graph. In acceleration time graph, x-axis we will take time, y-axis we will take acceleration. So graph will be on time axis like this. So that means no acceleration, not accelerating. Body is not accelerating. That indicates either at rest or moving with uniform velocity. Moving with uniform velocity or uniform motion. That indicates uniform velocity or uniform motion. Means no acceleration. Acceleration is zero. Acceleration is zero, but time is increasing. So body is at rest, acceleration is zero. Body is moving with uniform motion or uniform velocity, acceleration is zero. Next topic, equations of motion for vertically projected bodies and freely falling bodies. We know vertical projection and freely falling also. Now when the body is projected upwards with a initial velocity u, it reaches at a maximum height and its velocity becomes 0. Body started with initial velocity u, reaches maximum height h. At that point velocity becomes 0. At maximum height velocity becomes 0. Now displacement we can take h. Acceleration while going up minus g. So equations of motion, we have four equations that are v equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2as, s nth equal to u plus a by 2 into 2n minus 1. These equations can be written by using this data. If the body reached at maximum height, if they mention in the question, we can take v equal to 0. Maximum height, at maximum height velocity of the body becomes 0. So first time we'll take the formula by taking v. They can ask you at 10th second or after traveling midpoint, like that they can ask. At that point velocity is not 0. At maximum height only velocity becomes 0. Now we will see that equations how it will be. So as first equation is v equal to u plus at, v equal to u plus a becomes minus g into t. So it can be written v equal to u minus gt. Second equation, s equal to ut plus half a t square. So it can be written as h equal to ut plus half minus g. So minus I am writing here, minus half gt square. Third equation, v square minus u square equal to 2as. It can be written as v square minus u square equal to minus 2gh. And the fourth one, Snth equal to u plus a by 2 into 2n minus 1. It can be written as Hnth equal to u minus g by 2 2n minus 1. All a's are replaced with minus g. Next, if a body falling from a height under the gravitational force, we will take it is freely falling body. So for freely falling body, initial velocity is 0 and final velocity is v. Traveled distance s becomes h, and acceleration is coming down, no, plus g. So we have first equation v equal to u plus at, that can be written as v equal to u0, so g into t. Second equation, s equal to ut plus half a t square. So s becomes h, u0, so u into t 0, half gt square. H equal to half gt square. Third equation, v square minus u square equal to 2as. V square minus u square is 0, so equal to 2gh. From this one we can write v equal to root 2gh. Now fourth equation, snth equal to u plus a by 2 into 2n minus 1. So this can be written as u0 g by 2 into 2n minus 1. Hnth equal to this formula. And based on the situations, these formulas we can write in different forms. If they ask what is the maximum height reached by the body when a body projected with some initial velocity, what is the maximum height reached by the body? Now we'll come to here, we will use this formula. So here at maximum height v equal to 0, then minus u square equal to minus 2gh, so minus minus cancel, h maximum equal to u square by 2g. Like this we can use these formulas in the different situations. What is the time of freely falling body if it is released from a certain height? So t equal to 2h by g under root. By using first four equations we can derive many formulas as depends on situation. Thank you for watching. Please subscribe for more updates.